All right, I guess it's time. Okay, just a show of hands here. Who has done anything with Cosmos DB before? All right, just a couple. With anti-framework? All right, so more than half of the room, so that's good. All right, my name is Thiago Passos. I'm a solution architect and Brazilian, working in Australia for nearly 10 years. I've been working with the Microsoft technology for over 10 years as well. I've been a software developer for over 15 years, so I've been around for a while. That's my blog. If you want to have a look, so I try to post every month at least, with all the stuff that I've been doing, that I've been learning all the way. And if I have any code to share, then I often put in my GitHub, including the one that I'm gonna present here today. And if you want to get in touch, this is my Twitter handle. You can come and talk to me. So for the agenda today, so I'm gonna talk about what is Cosmos DB. So for most of you who hasn't done any Cosmos DB at all, so that's gonna be interesting. I'm gonna show you how to get started and how easy it is to get started. I'm gonna share some of the tooling that I use, and at the end, I'm gonna add EF Core to the mix and show you how we can manage our Cosmos DB instance with EF Core. Okay, so let's start with what is Cosmos DB. So Azure Cosmos DB is a multimodal database service for managing data at a planet scale, generally classified as NoSQL database. So from this sentence here, most of you know what NoSQL database is, and all of you would know what is scaling, right? But the multimodal here, when I started playing with Cosmos DB, was one point that I didn't understand quite clearly. So the multimodal means that Cosmos DB will handle multiple types of database. And with that, they have right now available 5 APIs that you can talk to Cosmos DB, including the core, which is like a SQL sort of way to talk to the database. They've got the MongoDB, Grammarly, Cassandra, and Table. So these available APIs you can set at the creation time of your instance, right? I'm gonna show you that. But think about Cosmos DB as a big umbrella. So you have all those database types, which all the APIs will fit into one of them. But all of them will provide all these amazing features, which is the global distribution, the ability to scale, the guaranteed low latency, these 5 consistency models, which I'm going to talk in a second. And they have a comprehensive SLA, which is a contract between Microsoft and the customers, which I'm going to talk briefly as well, which is pretty cool. Okay, so let's start with the global distribution. And this is probably the coolest part to look when you're talking about a database that scales out. Back in the day, if you had a SQL database, think about how hard it was. You still have SQL database nowadays, but think about how hard it was to keep 2 databases in sync. If you have one database here in the US and one in Australia, it would be pretty hard, right? So you would need to run like jobs overnight or things like that to make sure the database is in sync. So with the technology nowadays, what you can do with Cosmos is, I've got this instance in Australia, because I live there, so I've got this write region in Australia East. And to enable some read regions across the globe, I can just go and tick some boxes, and that's it. So now I have the database synced into multiple regions across the globe, and now I can get my data way faster. Okay, so that's how simple it is. So you don't need an IT expert to set up the whole infrastructure for you or set up any job to sync. So you've got that out of the box. What about the consistency levels? What's all that about? So Cosmos DB provides 5 consistency levels from top to bottom. You're going to pay more or less depending on what you choose. But this is what they are. So you've got the strong, which is the most expensive one. So no matter what region you are, you're going to get the data at the same time in the same order as it was written, right? So you're not going to have any delay, anything. You're just going to get the data no matter where you are. And then it goes down to the bounded Staleless, where you're going to have the write and the read region, which is going to be in a strong consistency. But all the other regions, you're going to have a slight delay, which is going to be 5 seconds or 100 versions, whichever is smaller, right? So for most of the scenarios, that's going to be good enough, right? So if you're here in the US and the data is delayed by 5 seconds in Australia, I guess that's all right in most of the cases, right? Then you have the session, which is the default consistency level in Cosmos when you create an instance. Which you have the regions, all the regions in the same session will have that strong consistency, and any other region will have a slight delay, which is going to be more than the bounded Staleless. It's not going to be a big deal either. Then you have the consistent prefix, which starts getting way more delayed, but the thing is, you're going to have the data coming in the same order, right? So if you write 10 records here in the US, eventually you're going to get the 10 records in Australia, but they're going to come in the same order, 1, 2, 3, and so on. And then you get to eventual consistency, right? So who knows about eventual consistency here and the whole concept? All right, so that's good. So eventual consistency is a pattern that you can apply, but in Cosmos DB, it's just a consistency level that you can select. Right, but eventual consistency, the first time I had a look at this chart here, it didn't make sense at all to me. Why would a person would want to use this level at all? Because as you're writing, you can see that you get the data in all different order, like with a delay. So it didn't make sense to me, like why the heck people would use that at all? But it makes a lot of sense in a lot of cases. For example, Amazon, not Amazon Web Services, but the store, they use the eventual consistency to sell products, right? So instead of checking the stock every time someone tried to purchase a product, they would just sell everything they could, and then eventually they would come back to the sales and check if the product is in store. And then if the product is not available anymore, they would just come back to the customer and say, all right, so we don't have that product anymore. Do you want a credit back? Do you want another product? What do you want? They found that this way is way more profitable because they're not going to stop the client from purchasing the product because it might get slow. They're just going to sell, and then eventually they're going to check the stock, right? So they took this compromise to do that later, but sell more. Okay, and the eventual consistency is that. So if you're dealing with a data that doesn't matter the order, for example, the number of retweets, the number of likes, the number of followers, this kind of stuff, you don't need an order, right? And eventually, when you stop writing, all the regions will come into sync, right? So it makes sense in a lot of scenarios. All right, so let's talk about the comprehensive SLA that the Cosmos DB provides. So they have these 4 agreements with availability, throughput, consistency, and latency, which is pretty much just the contract. And Azure says that if they don't deliver 99.99% of all of that, availability, consistency, throughput, and availability, or I said that twice. Anyway, so if they don't achieve that, they're going to give you 10% back. If they don't achieve 99%, they're going to give you 25% back, which is pretty great, isn't it? So it's ensuring that they're going to deliver what they're saying they're going to deliver, otherwise they're going to pay you back. Okay, so just a bit of why you would use Cosmos DB. So again, the global scalability, the fully managed, so it's serverless, the guaranteed low latency, reliability, and availability. But for us developer, so who here is a developer? All right, so hopefully most of the room, yeah, cool. So for a developer like me, I think the multiple APIs is the big deal because I don't need to learn a new way to talk to the database. So if I needed to learn MongoDB to be able to talk to Cosmos, that would be hard for me because I come from a SQL background, so I know SQL fairly well. And to learn a completely new language, that would be pretty hard. So I would have a steep learning curve. So having these multiple APIs, you wouldn't have any learning curve at all. Just a little bit, but not to the language you're gonna talk to the database, which is pretty good. Okay, so how to get started with Cosmos DB? Getting started is super easy, so I'm gonna show you that now. So if you go to the portal, you can just click on that plus button, search for Cosmos DB, and then you're gonna create your instance, and then you're gonna find, put some details, and then you're gonna choose your API. So that's the point where you choose your API. So you can't use different APIs to talk to Cosmos DB at the same time. So you gotta choose which API you're gonna use when you create. And that's the part that I was super excited about when I started using Cosmos DB, the quick start. So once you create your instance, you can go to the quick start, and then you can choose your platform. So I've been using .NET for a while and .NET Core for a while, so I choose .NET Core, and then you can create your sample items collection, right? And a collection in Cosmos DB is like a table in SQL, okay? So you can create your collection, and then you can download the source code, like a sample code. But the cool thing about that is when you download your sample code, it's linked to your instance, which is pretty cool. So a lot of the samples that you're gonna find around, you need to download the sample, and then you need to go through the documentation to see how you have to copy and paste your API key to make sure it's linked to your account. But when you download this, it gets synced to your instance, and you can just F5, and off you go, start putting data in your instance and see how it works. So this one is not using the EF core provider. It's just using the DocumentDB library from Azure. So I'm gonna open, and then after that you open Data Explorer, and then you can see how it works. But I'm gonna show you how it works. Okay, so I'm gonna go to the portal now. I've got an instance ready, and I'm going to go and create an items collection. So I'm gonna download the source code here. So I used to work for a company called SSW, and I had my MSDN subscription, but I left, so now I don't have an MSDN subscription anymore. So now I have to use another ID, which I'm using now, which is Rider. Who here has used Rider before from JetBrains? Yeah, I'm loving it. Yeah, I didn't want to pay that much for Visual Studio, so I'm using Rider, which is cheaper, but it does the job fairly well. Okay, so I'm just gonna open these now. So I hope it's not gonna take too long. Okay. All right, so the first thing they did wrong on Rider is putting the Solution Explorer on the left-hand side. That's wrong. It should be on the right-hand side. Yeah, yeah. Right, so it's just gonna finish restoring the package, and off we go. Okay, so I'm just gonna kick it off, pressing Ctrl F5. And then that should open the browser. This is a very vanilla MVC application. And it's pretty simple to understand. All right, so it's opening up. All right, so I've got the solution here. So I'm just gonna go back to the portal just so I can show you how the Explorer is and if I have any data there. So I'm gonna open the Data Explorer here. I'm gonna open in full screen. So we don't have any of these navigation here on the left-hand side. Okay, so I've got my to-do list, which is sort of the database, and the items is the sort of the table, the collection. So I don't have any document there right now. So I'm gonna go here and I'm going to create a few documents just to start with. I'm going to create buy milk on my way home. Okay, so I'm just gonna create a couple of more just so I can have some data to play with. Have breakfast with my JSON. Oh, I have to complete that. Hey, yeah, I'll get back that to complete. So bring, let's see. I think here. Okay, bring juice to for Brandon to drink. All right. So just one more. Drink more water in the morning. All right. So I'm just going to complete that. Have breakfast with my JSON because I already had breakfast with him. All right. So now I have 4 records or 4 documents, and one of them is completed. Okay. So let's go ahead here and refresh so we can see the data. So we've got 4 documents in here. So you can see that we have all the documents on the right hand side, and with this have breakfast is completed. Okay, so what I'm going to do, I'm going to open a new SQL query, and you can see that that looks very, very similar to a transact SQL, right? To the SQL syntax. The only key difference here is this C. What's that about? Select stuff from C. C is not the name of the collection. So C in Cosmos DB is just an alias, so you can put pretty much anything you want there, right? And that's because the statement is linked to the collection. When you run something, the context of that is not the whole database, is the collection itself, right? So that's why there is an alias there, because there is no cross reference between collections. All right, so let's run that to see if we get the 4 records. All right, so I've got the 4 records here. Cool. So let's put a condition here so we can see how we can filter the data. So C is complete. Complete. My type is horrible. Equals true. Okay, so if we run that, that should work. I've got the is complete true. I've got 1 record. But what I can do as well, I can remove the true, and that still works because it's almost like JavaScript, right? I can put a not, and it also works. That's good. What else can I do here? So let's change that to be CName like beer. That's a valid SQL command, isn't it? All right, so let's see if that works. All right, so that doesn't work. So the transact SQL for Cosmos is slightly different. So for that, we need to put contains and beer. So it's almost like JavaScript. So let's run that. Okay, so we don't have any results. Should have beer in there, shouldn't we? Didn't put any beer there? Oh God, no, I'm gonna check that. I'm sure I had beers there, so let me check that. So I'm gonna run again. Try water, all right, so I'll try water. Yeah, there's juice, there is breakfast, water. Yeah, there is a problem there. I gotta fix this problem eventually, so let's see that. So where contains CName, water. All right, so that should work then. Oof, that works. All right, so that's working. All right, so Cosmos also has the same way to put the alias for the fields as well. So I can select which fields I want to bring back. Okay, the same way as SQL. So I'm bringing only 3 fields. Okay. So if I want to just filter which sort of fields I want to bring back. All right. What else I'm going to show here? So Cosmos DB has the same concept of store procedures and functions in the database. And the cool thing is it's like a JavaScript function, right? So it's really simple to understand and to write. So let's create a new user-defined function here to fix my problem. So I'm going to create one called BRFI, okay, which is going to bring, it's going to take a value, and it's going to return value dot replace. I'm going to create this regular expression in a sec. So who here likes regular expressions? Only me and a couple? Oh, cool. I love regular expression. All right, so I'm going to create a regular expression here. It's going to modify globally and with case and sensitivity. And I'm going to put a few things here. I'm going to put juice, water, breakfast, and milk. Cool. All right, so my function is done. So I'm going to save that. And I'm going to use that function now. So I'm going to go back to my query, and I'm going to put user-defined function, BRFI. And I'm just going to put the label here because the alias, because I want the same name. I'm going to run that. All right, so now I have buy beer on my way back home, have beer with my mate Jason. Oops. There you go. Bring beer for Brandon to drink, and drink more beer in the morning. I don't know how my liver is gonna survive after that, but yeah, that's all good. Okay, so that's just so you can understand how easy it is to modify the data if you need to. And just the last thing before I move on, Cosmos DB also have the trigger that I didn't talk about, which is also like a JavaScript function, and it works pretty much the same way as a JavaScript function. Okay, and you can bind that to some of these events in your Cosmos DB instance. What you can do as well, you can bind to an actual Azure function, which is pretty interesting. Okay. All right. So let's move on and talk about the tooling. So there was an event that I went about a year ago, and I talked about logic apps. Okay. So I was playing around logic apps, and I was presenting about it. And for this talk, I put together a solution that was getting a bunch of tweets for that conference, and was putting all that in a Cosmos DB instance. So I was pretty happy with the solution. It was running cognitive services at the back and stuff like that. But at the end of the conference, I didn't have anything to do with the database. But I didn't want to lose either. I wanted to check the data and see what I could do with the data, just to play with the data. So I left there, and I kind of forgot. Like, yeah, eventually I'm gonna play with that. So I was charged like $100 every month. But I was, oh my God, I need to do something with it. But I didn't know the tool to get data, to migrate data out of that instance. So eventually I found out about this data and about this tool, and it saved me like $100 a month after that, which is good. So this tool is called Data Migration. It was originally created for DocumentDB, which is an early version of the previous version of Cosmos DB, even though they're not the same product. But yeah, so it was created for DocumentDB originally. Let me show you how it works. It's super simple. So I'm gonna use the same instance. So I've got that in the cloud right now, the Cosmos DB instance, and I'm gonna run this data migration tool. So I'm gonna select here DocumentDB. Okay, so I need to get this connection string from my instance. So let me go there. Let me copy that. Don't take any pictures, please. All right, so I'm gonna copy that. So let me see, the name of the database is to-do list. All right, so I'm gonna paste the connection string here. I'm gonna put the database equal to-do list. All right, and the collection is items. And then I can write any query here to bring the data, but I'm going to just do select stuff from C. And I'm going to put that into a JSON file. All right, so I'm going to save that as a to-dos, okay, in the desktop. All right, so I could prefix if I wanted, but I'm just going to keep going as is. And I'm going to import the data. Okay, so if we have a look at the to-dos.json, you're going to see that I have a collection of every single record that I put in the database. So it's still broken here because I have breakfast, I have water, so I should have done something about it, but yeah, it's all working well. The next tool that you want to use, if you're going to do anything with Cosmos DB, even if you're learning, is the Cosmos DB Emulator. Just FYI, this is only for Windows, so you can't use that for Mac, unfortunately. They might create eventually a version for Mac and for Linux. But this tool is just for Windows. So let's see how that works. So I'm gonna kick off the Cosmos emulator here. All right, so let me look for it. So Azure Cosmos DB emulator. Computer, don't die on me. All right. So I've got that running. Okay. All right, so let me see. All right, so it kicked off here. So you can see it looks very similar to the Azure portal itself, but it's running on the local host, which is pretty cool. So what I'm going to do now, I'm going to copy that connection string, and I'm going to update that quick start demo so I can run that locally. All right. So I'm going to go here to my quick start. So in the document DB repository, I've got the key here. So one thing I would change on this quick start is having all this data here in a JSON file, in a app settings or something like that. I don't like that this isn't the code, but well, that works. I can change that later. Okay, so I'm just gonna update these and run again the solution to see if it is that simple to connect to another instance. All right, it's kicking off. All right, so you're gonna see that if I go to the collection now, the Explorer, I've got the collection in there already. I don't have any documents, but it's there because as soon as I kicked off, it created for me. So I'm gonna create a new record here just to try it out. That's a local instance. And I'm going to create. So if I go back here, refresh, I've got that in. So I can now use, develop with Azure Cosmos DB locally, and then eventually when I want to deploy that, I can just use an instance in the cloud. Okay. All right, so let's move on. Okay, now that you have your local environment, let's start playing with Cosmos DB and get that EF core to the mix. But before I move on, I just want to tell a bit of a story when I started playing with this provider, right? So for those who know NT Framework or EF core, you know that for you to connect to SQL, you need to bring a provider, which is the NT Framework core SQL. So you can connect to Oracle, you can connect to Postgres and things like that. And they came up with the idea to bring a provider for Cosmos DB, and I was pretty excited. I was super excited, and that was over a year ago. And I found out about it, and I was looking forward for them to release a beta version, whatever version, so I could play with. And eventually they did, and I was super excited. I started using it. I actually wrote a blog post about it, describing every single step to make it work. So I was super happy about it. And a couple of months later, I was invited to speak in a conference and to talk about Cosmos DB. And I thought, all right, that should be easy. I've got a blog post about it. I can just go there. I can replicate the steps. I can see how it works, and I can put together a talk. That's easy. And then I started putting together the talk, and when I came to the demo part, I went there and I tried to install the same package that I installed back in the day, and the package wasn't coming up. What's going on? So I tried multiple times. I tried copy and pasting the name of the package. I'm sure it's right. And then eventually I found a link that went straight to NuGet, because I went to NuGet.org and I couldn't find either the package, and was something wrong. And then eventually I found the package, and I was happy. So I could find the package, microsoft.entityframework.cosmos.sql. That's so good. Now I can move on and I can prepare my talk. That's good. But then I found this yellow box there saying the owner has unlisted this package. This could mean that the package is deprecated or shouldn't be used anymore. And I was about to talk in a conference, and I was freaking out. Like, how can I present on something that's deprecated? Like, I can't do that. But eventually I found out that they just dropped the .sql at the end, and I was happy again. All right, so let's see how it works. Okay, so I'm going to use the same local instance. I'm going to use a sample code that I created before. I'm just going to copy that connection string again so I can use in my sample code. Again, I'm going to use writer. So this is a pretty vanilla implementation as well. So I'm using the CQRS pattern and all, but it's actually pretty simple. And all I'm doing is hooking up an Angular front end with the API, and I'm talking to the persistence using Cosmos. All right, so it's nothing complicated here. Okay, so let's load the project. Okay, so here are my project. So in the web, all I'm gonna do here is update the app settings, which should be in the quick start, but it's not. But anyway, that's all right. So I'm gonna copy that private key. Let me remove some stuff here, the private key here. And the DB name is gonna be blog, because I'm gonna create my blog with this solution. It's probably a bit over engineering, isn't it, for a blog? All right, so you can see that in the domain, I've got author, category, and post, which are super simple. Okay, so if I open the post here, you're gonna see that I've got an ID, I've got author and category, nothing fancy there. Okay, so in the controller, I've got the post controller, which is not fully implemented. And all I have here is to get all posts and to create a new post. Okay, so I'm injecting here the commands. All right. And this one is to get all. So if I go, if I go into the command, you can see that all I'm doing, I'm getting the model here, I'm creating the entity, I'm binding the data coming from the model. So every time I'm creating a new author, a new category, which I could fix that later, but for now that's going to suffice. And then I'm adding the post to the posts table or collection. All right, so that's pretty vanilla, a vanilla implementation of EF. Okay. All right, so what else here? Okay. All right, so let's have a quick look at the persistence layer. So in my DB context, all I have is 3 DB sets. It's pretty straightforward. And in the constructor, I'm just ensuring the creation of the database. So if the database is not created, it's going to create for me. In this case, it's going to create the instance of Cosmos and the collection and so on. And then when it comes to hooking up the DB context with Cosmos, the same way I would do with SQL by doing use SQL, I'm going to do use Cosmos. So that's all you need to do, and bring the entity framework Cosmos into the play here. All right, so nothing too fancy. All right, so let me try. I'm going to run the solution now and see how that plays. So I've got an Angular front end and using this API in the back end. Very simple UI. So I'm gonna have a look at the Data Explorer here. You can see that I've got a blog, and I've got a blog DB context as the collection, which is something that I found weird when I created the first time. Okay, so you can see that I have no documents in here. All right. Okay, so now what I'm going to do, I'm going to create a new post and see if the data goes through and how the data comes through. Okay, getting started with Cosmos DB. The category is going to be Cosmos, author, Thiago Passos, and the content's awesome. Okay, so I'm going to create that. And I'm going to see how the data is structured in Cosmos. Okay, so if I come here and refresh, I'm gonna see 3 different records. And when I saw that the first time, I found it was really weird. Why would I have 3 records? And then I had a look at the first document, and you can see that the content is awesome. So it is a post, the discriminator is post, and the title is getting started. And I have a link to author and category, all right, 2 different entities. And then you see that in the other documents, they are the category and the author. So it's actually a clever implementation, because then you have the polymorphism out of the box with no configuration, which is pretty cool. So to do that in SQL, it would be pretty painful. So I did that in the past, and it was really painful. But the one thing that I didn't like was the blog DB context as being the name of the collection, and that's the first thing I wanna fix, right? So I want the collection to be called something more meaningful than the name of the DB context. So what I'm gonna do here, I'm going to use the onModel creating to override the default name, the convention, which is the name of the DB context. So I'm gonna get the infrastructure here using Cosmos, and I'm gonna override the container name here to default. So now any record that goes into the Azure Cosmos DB is gonna be created in this default container, all right, in this default collection. So if I run now, what I'm expecting to see now is, as soon as I run, is a new collection coming up as default, okay? So let's refresh this. All right, so if I go to the Explorer here, you see that I now have a new collection called default, which I'm overriding the name. And if I create a new post, all right, create a post, Cosmos DB, category Cosmos, author Thiago, and content, great, okay. All right, so now I have the same thing, but with a slight improvement, because now I have control over the name of the collection I want to use. Okay, but what if I want to not use the same collection for every single entity that I have in my DB context? How do I do that? So that's the next thing I want to fix, right? So now what I want to do is I want to override the fact that every single collection, every single entity is put in the same collection. So I'm gonna also use the model builder, but I'm gonna get the entity post this time, and I'm gonna set the container name for that to be the name of post, which is posts. Okay, so now what I'm expecting to see is when I create a new post, the data is gonna, the post itself is gonna be created in a posts collection, and everything else is gonna land in the default collection. Which makes a lot of sense in a lot of cases, because each collection, you can scale each collection separately. So you can leave all the auxiliary data in a default collection. All right, so let's create a post here to see how that looks. Okay. All right, so I now have a new post here. So if I refresh, I'm gonna have one record in posts. And if I go back to the default collection, I'm going to have 5 records because I already had 3, so now I have 2 more. All right, so that's way better, especially for me that I come from a SQL background. Having that link to a single collection didn't look right. So if you want to go further and create a collection for every single entity of every single DB set, you can write some code. I'm using reflection in this case because I'm going through all the DB sets in my DB context, and I'm setting the name, the container name for that DB set. I often wouldn't suggest that, but it's just for the sake of an example to show you that you can do that. But I often wouldn't do that because if you have a lot of data that are not used that often, I would put that in a single collection so you don't need to scale up as much, right? But just to show you here, so as soon as it refreshes, the one post, the first post that's there already is gonna come without a category and without an author because they are now linked to a different collection. So you couldn't find that in the right collection. Okay, so if I refresh this, I'm gonna see a new collection called authors and a new collection called categories. Okay. All right, so let's create a new one here just to show you how it works. All right, add, cool. All right, so let's see that coming back. Cool, now I'm going to refresh the authors collection. Now I have an author, and now I have a category. And in the post now, a new post comes up. Cool. All right, so that's the implementation of the EF core provider for Cosmos DB. And if you want to know more about this provider and how they're progressing, I created a Bitly link so you can have a look. So it's a Git issue that you can go ahead and check it out. So they have a lot of features already implemented. So if you want to use that even in production, just go ahead and use it. I've been using .NET Core since it was beta 4 or something. It was called VNext at the time. And we didn't have many issues. But yeah, just have a look. If it's enough for your needs, just go ahead and use it. It's awesome. I've been pretty happy about it. I actually, one of the projects that I'm working on, I had a SQL database where I was ingesting a lot of data, and SQL wasn't handling that much data coming at the same time. So I thought, let me change that to Cosmos and see how it plays. So now that I changed to Cosmos, I can handle 10 times the amount of data that's coming through, and I'm actually paying half of the price that I was paying for SQL because I actually had to bump up SQL a fair bit to be able to handle the load. And Cosmos DB is just handling as a champ, so it's amazing. All right, so let's summarize here what and why. So you should use just because it's awesome. That's it. The getting started experience is amazing. It's one of the best ones I've seen around. The wiring up with EF Core, the implementation is pretty clever, and I'm pretty happy about it. And some of the tooling that I showed you and having the local instance to play with is really interesting. And what's next? Have a look at the task list. See if it's enough for you to start play with, and give it a go. That's it. Thank you. Cool. Any questions?
Do you know when it's going to be released to RTM?
They don't have a time yet, but it's pretty close actually. So if you go to the task list, the RTM is coming, I don't know, in the 2 versions. It's 2 versions behind the RTM. So I would assume it's pretty soon. Any more questions? All right, thank you very much.